Hello friends and welcome to YouTube channel on Engineering Mathematics by Dr. Navneet. Friends, in this video lecture we are going to learn the concept that is called as vector differentiation, and particularly we are learning the concept that is called as directional derivative. In short, we are abbreviating the concept of directional derivative as DD. So DD stands for directional derivative. So before solving the example based on this directional derivative, so let's first try to understand the meaning of directional derivative and some related result. So here, if let the function phi of xyz be a scalar point function, then the partial derivative of phi with respect to x, partial derivative of phi with respect to y, and partial derivative of phi with respect to z are the directional derivative in the direction of coordinate axis. That means this partial derivative of phi with respect to x denote the partial derivative along x axis. This is the partial derivative of phi with respect to y denote the directional derivative along y axis, and similarly partial derivative of phi with respect to z denote the directional derivative along z axis. Similarly, this is for the scalar point function. Similarly, for the vector point function, if f of x, y, z be the vector point function, then partial derivative of f with respect to x, partial derivative of f with respect to y, and partial derivative of f with respect to z are the directional derivative in the direction of coordinate axis. So this is for the scalar point function, and these are the concept which is related to the vector point function. Now friends, in this video lecture our main focus is to how to find the value of directional derivative in the direction of a vector A. So for this, so directional derivative in the direction of vector A bar, so we are learning, or we are solving the example based on this concept. So the directional derivative of scalar point function phi in the direction of vector A bar is given as del phi dot A bar upon magnitude of A bar. So this is the formula to solve the example based on the directional derivative. So this is the directional derivative of a vector A bar. So now friends, here while solving the example based on this function, so first find out the value of del phi. So del phi stands for gradient of phi, and which is defined as del phi is equal to I time partial derivative of phi with respect to x plus j time partial derivative of phi with respect to y plus k time partial derivative of phi with respect to z. So then take the dot product of this del phi with vector A bar, then divide this dot product with magnitude of A bar, so we get the direction derivative in the direction of vector A bar. So this is the theory part which is related to the direction derivative in the direction of A bar. Now friends, to take the dot product of this del phi dot A bar, use the formula. Suppose vector A bar is defined as a1i plus a2j plus a3k. Similarly, another vector B is defined as b1i plus b2j plus b3k. Then their dot product A bar dot B bar is defined as, so take the product of unit vector I term coefficient, that means a1 b1 plus a2 b2 plus a3 b3. So this is the way to define the dot product between two vectors. Now friends, here the first example, which is very simple. Example is find the directional derivative of a scalar point function phi, which is defined as xy square plus y z square at the point 2, minus 1 and 1. That means after finding this directional derivative, in particular put x is equal to 2, y is equal to minus 1 and z is equal to 1 in the direction of vector 2i plus j plus 3k. So friends, here one scalar is given, and our aim is to find out the directional derivative in the direction of this vector. That means this concept is same as that of the directional derivative in the direction of vector A bar. So we know the formula for this. So we know that, directional derivative of scalar point function phi of x, y, z in the direction of vector A bar, which is defined as del phi dot product with A bar upon magnitude of A bar. So this is the formula for finding the directional derivative. So if we try to solve this example with the help of this formula, then here the value of scalar point function which is given by phi, and the value of phi is x y square plus y z square. So this is the value of phi. Now find the value of a. So this a denote in the direction of vector. So in the direction of vector, so value of a, so which is given as 2i plus j plus 3k. So this is the value of vector a. Now friends, to find out the directional derivative in this in the direction of vector a bar, which is defined by this term, so formula is del phi dot a bar upon magnitude of a bar. So our first aim is to find out the value of del phi. So if we try to find the value of del phi, so then we know the formula for del phi. Del phi stands for I time partial derivative of phi with respect to x plus j time partial derivative of phi with respect to y plus k time partial derivative of phi with respect to z. So we can write this as I time partial derivative of phi with respect to x plus j time partial derivative of phi with respect to y plus k time partial derivative of phi with respect to z. So if we try to find the partial derivative of this phi with respect to x, when we take the derivative with respect to x, y and z are constant. So now take the derivative of this term with respect to x. So we get this as y square into I plus take the partial derivative of this term with respect to y. So then we get this as 2xy, because derivative of y square is 2y into this x is constant. Then plus this is z square into j, plus again take the derivative of this function with respect to z, which is 2yz into k, because derivative of z square is 2z, this y is constant. So this is the value of del phi. That means this is also called as gradient of phi, which is defined by this function. But here the points are given, so that means find out this value of del phi at the point 2, minus 1 and 1. So we get this value as, so this is y square, that means 1 square is 1, so this value is I. Now just put this value, so we get this as 2 into minus 1 plus this is 1 square is 1 into I plus this is 2 into minus 1 into 1 into k. If we try to simplify this, then we get this as I plus this is 2 to the 4 minus 4 and plus 1, this is 2 to the 4 minus 4 and 1, that means this is minus 3. So we can write this as minus 3j. Then this is again minus 2. So we can write this as minus 2k. So this is the value of gradient of phi at the point 2, minus 1 and 1. So we find the term del phi. Now next thing is that find the vector a bar. So a bar is already given here, which is 2i plus j plus 3k. Now next step is that find out the magnitude of a. If we try to find out the magnitude of a, then we know the formula for magnitude of a, which is x square plus y square plus z square if vector is defined as xi plus yj plus zk. Then we can write it magnitude as, so coefficient or x value is 2, or 2 square is 4 plus 1 square is 1 plus 3 square is 9. So we can find this magnitude as root of 14. So in this way we can easily get the value of this term. We get the value of a. Now next step is that find out the value of dot product of del phi with a bar. So this is the value of del phi, its dot product with a bar, which is defined as I minus 3j minus 2k. So this is the value of del phi. So del phi at the point 2, minus 1 and 1. Its dot product with a bar, so we can write this as dot product with vector a. So vector a is defined as 2i plus j plus 3k. So now to find out the dot product. So now friends, we know that how to find the dot product between two vectors. So this is the first vector, this is the second vector. While finding the dot product of these two vectors, so take the product of I term coefficient. That means a1 b1, a2 b2 and a3 b3. So here we can take the product between these two terms. So we get this as 2 into 1 is 1. Then next term is minus 3 and 1. So we get this as minus 3. Then this is minus 2 and this is 3. So we get this as 3 to the 6. That means in general we get the value of this term as 2, 9, minus 9, 2, that means this is minus 7. So if we try to find the directional derivative, so therefore directional derivative is equal to del phi dot product with a bar upon magnitude of a bar, and which is given as, so this dot product del phi dot a bar, which is minus 7 divided by, so magnitude of a bar is root of 14. So in this way, friends, we get the solution which is related to this question. So in similarly in another question, so value of this scalar point function may get changed, this vector a may get changed, or this point may get changed, but concept of solving the example is always same. So this is the first example related to the directional derivative in the direction of vector a bar. So now, friends, let's take the second example. Now, friends, here the second example is find the directional derivative of scalar phi, which is defined as x square y cos z at the point 1, 2 and pi by 2 in the direction of vector a bar, which is defined as 2i plus 3j plus 2k. So let's apply this formula. So we know the directional derivative. So value of directional derivative is equal to, so this is del phi dot a bar upon magnitude of a bar. So this is the formula of directional derivative in the direction of vector a bar. So now here, friends, the value of a scalar function phi or scalar point function phi is defined as x square y into cos z, and that of vector in the direction of vector a, which is defined as 2i plus 3j plus 2k. So this is the value of vector a bar. Now, friends, to find out the directional derivative, that means find out the value of first del phi. So let's write down the first definition of del phi, which is defined as derivative of phi with respect to x plus j time derivative of phi with respect to y plus k time derivative of phi with respect to z. So this is the definition of gradient of phi or del phi. So now let's find out the partial derivative of this phi with respect to x. So when we take the partial derivative with respect to x, y and z are constant. So derivative of this term is 2xy, then this is cos of z. Because y and cos of z is constant, derivative of x square is 2x into this is I plus partial derivative of this term with respect to y. So this x square and cos z is constant, and derivative of y with respect to y is 1. Plus next is derivative of this phi now with respect to z. So when we take the derivative with respect to z, then x square y is a constant. The derivative of cos x is minus sin x. We can write this as minus time sine of z into this k term. So in this way we can easily find out the value of gradient of phi or del phi. Now, friends, find out this gradient of phi at the point, that means find out the value of grad phi at the point 1, 2 and pi by 2. So we get this as, so put x is equal to 1, so we get this as 2 into 1 into 2 into this is cos of pi by 2 and I plus this is x square, value of x square is 1, so this is 1 square is 1, then this is again cos of z, that means cos of pi by 2 into j plus here put the value of x again, so this minus as it is, 1 square is 1, then this is into 2, then this is cos, then become this is a sine of pi by 2 into k. So friends, we know the some important formula. So formula is that, so value of this cos of pi by 2 is always 0, and that of sine of pi by 2 is equal to 1. So these are the standard trigonometric formula. So if we apply this formula, then we get this value as, so here cos of pi by 2 is there, so in product with this term, so this term become 0i plus again here cos of pi by 2 is there, so this whole term becomes 0, so this is 0j. Now here sine of pi by 2 is 1, so that's why we can write this as minus 2k. So this is minus 2 and this k sine of pi by 2 is 1. So this is the value of del phi at the point 1, 2 and pi by 2. So that means we get this as value of del phi. Now find the value of vector a bar. Now vector a bar is already given here. Now find out its magnitude. Now to find the value of magnitude of a bar, which is defined as, so this is x square plus y square plus z square if vector a bar is of the form xi plus yj plus zk. So if we try to simplify this, then we get this as x square, value of x square is 2, so this is 2 square is 4 plus 3 square is 9 plus 2 square is again 4, and finally we get this value as 17, so root of 17. Root of 17 is the value of magnitude of a bar. Now next step is to find out the dot product of del phi dot a bar. So now to get this denominator value, so take the dot product between these two vectors. So this value is 0i plus 0j minus 2k, and its dot product with vector a bar. So a bar is defined as 2i plus 3j plus 2k. Now to find out the dot product between these two terms, that means we are applying this concept. So take the product of I term coefficient, jj term coefficient, and kk term coefficient. So now here we take the product of this 2 into 0, that means this is again 0. Then next is plus, this is 3 into 0, so we get this as 0. Then minus 2 and 2, so we get this as minus 4. And so finally we reach to the answer as minus 4. So dot product of these two terms. So now friends, therefore we find the directional derivative of this term as del phi dot a bar upon magnitude of a bar, and which is given as, so this is minus 4 divided by magnitude is root of 17. So this is the easy method to solve or to find out the value of directional derivative in the direction of vector a bar. So now after this second example, let's take some example for your practice purpose. Now friends, time is to test your knowledge. So for your practice purpose, total 4 examples are given. So find the directional derivative of this example. So where the scalar point function phi is defined as phi of x, y, z, which is x, y square plus y, z cube at the point 2, minus 1, 1 in the direction of vector a bar, which is defined as I plus 2j plus 2k. And answer is minus 11 by 3. Now friends, here second example is phi is defined as xy plus yz plus zx at the point 1, 2, 3 in the direction of vector 3i plus 4j plus 5k. And this is the answer which is related to question number 2, which is 46 upon 5 root 2. Then third example is phi, that means scalar point function is defined as 4xz square plus x square yz at the point 1, minus 2 and 1 in the direction of vector 2i minus j minus 2k. So again use the concept same as that of this one, and you will reach to the answer as 37 upon 3. And the last example is find the directional derivative of scalar point function phi, which is defined as 4x z cube minus 3x square y square z at the point 2, minus 1, 2 in the direction of I plus j plus k. And answer to this question is 140 divided by root of 3. So solve this 4 example as a practice purpose. So friends, I hope you people like this lecture. So thanks to one and all for watching this video. Thank you.